Hi friends, today we are going to discuss about the concept of a linear programming problem. Its short form is LPP. There are different methods of solving linear programming problem. So the topic of discussion in this video is simplex method. Actually the concept of LPP was recognized by George B. Dancing. He is a pioneer in linear programming. In 1947, he published the first paper of a simplex model or simplex method. So up to that particular time period, so many other researchers also joined him for conducting or developing and exploring the new application of LPP. LPP is not applicable to at a particular single area. It can apply in different field, different segments. So it is actually an interdisciplinary topic also. So we can apply the same thing in computer technology. You can apply the same thing in production. So we can apply that one in different areas. So today we are going to discuss about that is a simplex method and how to solve a problem by using simplex method, and that is especially how to solve a problem of a maximization problem. That is especially two types of problems are there. One is maximization problem and the second one is the minimization problem. So object of maximization means there will be the certain object of maximizing the profit. So if you are looking at the profit angle, the object is maximization of profit. If you are looking at a cost perspective, you are going to look at minimizing the cost factor. Two situations are there. One is maximizing the profit, and the second one is minimizing the cost factor. So let us move to the first situation. Simplex is an algorithm. So it follows certain mathematical steps, and following the mathematical steps by using preparing certain tables and calculations and all the things are there. So that will be continuously using up to get a desired result. So we are going through a maximization situation. So the object of a maximization situation is to maximizing the profit. Moreover, we are going through different things, different aspects, different situations, different variables. So we are including certain variables into normal solution and make it into a perfect one. So I'll give you an example. This is a question having three components, like objective function is there, subjective functions are there, and non-negativity factors are there. And the objective function here is maximize z is equal to 7x1 plus 5x2. Subjective constraint means x1 plus 2x2 less than or equal to 6. And second subjective constraint is equal to 4x1 plus 3x2 less than or equal to 12. And your non-negativity variable is equal to x1 comma x2 greater than or equal to 0. So here we have an objective function. So maximizing the z value of x1 and x2, that is 7x1 and 5x2, you have to fulfill certain subjective conditions. That is first condition is x1 plus 2x2 less than or equal to 6 and 4x1 plus 3x2 less than or equal to 12, and always the value is greater than or equal to 0. So you have a linear programming equation like this. In order to solve the problem into simplex method, you have to look at certain steps, and the first one, you have to convert your inequalities or subjective constraints into equations by introducing one more additional variable, that is called a slack variable. That is the first point you have to remember. So in order to in order to solve a particular LPP problem into simplex method, so you have to convert your inequalities into equations by introducing an additional variable that is called slack variables. Then you can convert the first equation like this: x1 plus 2x2 plus s1, that is the first slack, is equal to 6, that is equation number 1, and 4x1 plus 3x2 plus s2 is equal to 12, that is equation number 2. So we can convert this to one into equations by introducing slack variables. So here the slack variables are: s1 is the first slack variable and s2 is the second slack variable. These are the slack variables. Then in this equation, the next step is you consider the value of x1 and x2 is equal to 0 in equation number 1 and equation number 2. Then the value of s1 is equal to 6 and value of s2 is equal to 12. That is the next process. So x1, x2 are you considered as 0 in the first and second equation. Then the value of s1 is equal to 6 and s2 is equal to 12. Then based on these things, you are making a calculation table. So where there will be values of x1, x2, s1, s2 and xb. So based on equation number 1, you take the numerical numbers only. X1 is equal 1x1 means x1, then 2x2 2, s1 is 1s1 and s2 is there is no s2, so that is why in equation number 1 there is no s2, so it is 0. And the final value is xb value is equal to 6, that you have calculated when s1 x2 is equal to 0 in equation number 1 and 2. Then you have to get the value of s1 and s2, that is 6, and second equation, that is 4, 3, 0 and 1, and xb value is 12. So that is what this is not actually not in some of the textbook. This is which I have calculated for just for identifying the values. Then next step is you can rewrite your objective function after introducing the slack variable. So once you are introducing the slack variable, then you have to rewrite your objective function like this by adding the slack variable. So 7x1 plus 5s2, that is already it is there, plus 0s1 plus 0s2 plus 0s1 plus 0s2. So one more thing you have to remember: the value of a slack variable in the objective function is 0. Always the value of slack variable in the objective function is 0. That is the important point. So the value of a slack variable in the objective function is 0. Based on which you can write another rough calculation table like this. Here you take the x1 is equal to 7, x2 is equal to 5, s1 is equal to 0 and s2 is equal to 1. So that is called a Cj or Cb values. We can call it a Cj or a Cb. I will tell you what is Cj and Cb in the later on part. So just note down this is called Cj and Cb values. Let us see, this is a simplex table having for solving this equation, that particular situation. So having the columns name, that is B, CB, XB, X1, X2, S1, S2 and minimum ratio, then Zj, Cj and Zj minus Cj. So I will tell you what is the things that is there in the this B, CB and XB, then what is Zj, Cj and all that things. So name of the xb variable is called B. So name of the xb variable is called B. So here the name of xb variable s1, s2 is there. So s1 is in the first row and s2 is in the second row. Then cb is the actually cb is the objective function value of a xb variable. So there will be an objective function value of a xb variable. So here we take s1 and s2. The objective function value of s1 and s2 is that is 0. Then if you take x1, of course you take the objective function value of x1. If you take x2, then you take the objective function value of x2. So here you take the SB variable based on x1 and x2 is equal to 0. Then based on which you get the first xb values. So you will have s1 and s2. The objective function value of s1 and s2 is 0. Then xb is the value of the variable. So when you put the s1 and s2 is equal to 0, then you will get the value of s1 and s2. You have calculated the value in the previous slides. So that is the value you have to put it here. That is called xb variable values in column. Then the next one is a Zj value. Zj you have to calculate like this. You have to multiply your CB value into, for example, you take the x1 column situation, you multiply your CB with the x1, CB first row value with the x1 first row value, plus CB second row value with the x1 second row value. For example, CB value is 1 and the x1 value is 1. So first row 1 into 1 plus if the second one is 2 into 1, 2 and 1 is there, then 2 into 1. So 1 into 1 plus 2 into 1 will be the sum of Zj value of x1. So likewise, you have to calculate all the value of x1, x2, s1 and s2. Then what is Cj? Cj is the objective function value. We already tell the Cj and Cb are the objective function values. So just before we have mentioned about the values, that is 7, 5 or something like that you have to calculate it. So this is the objective function values. Then the next one is what is Zj minus Cj. So it is the difference between Zj and Cj column. That is the first Zj values are there, Cj values are, take the difference. So when you calculate the Zj minus Cj values, the solution is said to be optimal when all the Zj minus Cj values are positive. If your Zj minus Cj values are positive, then automatically your solution will be optimal one. So in other ways, you have to go for the further step. For that, we need a minimum ratio and all. So I just to tell you what is the minimum ratio. I'll explain again in the next part. So minimum ratio is the ratio of xb divided by key column. It is the ratio of xb divided by key column. So I will tell while discussing the problem, I will tell how to calculate this particular one and all. So just note down, it is the ratio of xb and key column. Xb divided, not the ratio, it is the division of xb, you have to divide with the key column values. Then this is the simplex table 1. So you have the values of 0, s1, you take the first row, s1, the cb is 0, xb 6, x1, x2, s1, s2. So based on your calculation table, you have noted down the values. Then you take the s2 values, 0, 12, 4, 3, 0, 1. It is based on your previous calculated values. Then Zj, here 0 into 1 plus 0 into 4. So it is 0 is there, Cb, so automatically all the values are 0. So for example, in case of x2, 0 into 2 plus 0 into 3. And s1, 0 into 1 plus 0 into 0. And s2, 0 into 0 plus 0 into 1. So you have to summarize the values and that will be the Zj situation. And Cj is the objective function values or objective function variables, and you take the difference of Zj minus Cj. So look at this Zj minus Cj value, minus 7, minus 5, 0 and 0. If you are looking at this one, you can see that there will be a negative in the Zj minus Cj value. So you can say, you can tell that the solution is not optimal. And since Zj minus Cj values shows a negative sign. So then the next process we are looking down. So identify the least negative value. Here it is minus 5 and minus 7. So minus 5 is the least value. So that column is called, that is called x1, that column, that is called a key column. So the next process is identifying the least negative value. So that is minus 7. So the column x1 is the key column, and the next process is the calculation of a minimum ratio. Minimum ratio, as we discussed earlier, so that is a ratio of xb divided by key column values. Here key column is x1 and xb is there, and 6 by 1 and 12 by 4. So 6 by 1 is 6 and 12 by 4 is equal to 3. From the minimum ratio column, you have to take the minimum value of the ratio, that is 3. So look at 6 is the one value and 3 is the other value, then you take the 3. So that corresponding row is called a key row. That corresponding row is called a key row. So the intersection of these two, that is key column and key element, key row is called a key element. So it is otherwise called a pivot element. So key column is otherwise called a pivot column, and key row is otherwise called a pivot row, and the intersection element is otherwise called a key element. So that is another one. Then the next one, you are going to interchange. So you have to, your x1 is coming in, that is called a key column is coming inside, and key row is going outside. So x1 is coming inside and s2 is going outside. Now the simplex table will be like this: s1 and x1. So you can redraft your simplex table like this: x1 and s1. Then you have to go through the next process. Now you have two rows, and s1 is the existing row and x1 is the new row. S1 is the existing row and x1 is the new row. Then first of all, you calculate the new row element values, that is new row element values, that is called x1. x1 is the new row. Then you have to calculate the new row element values. So the equation is original element divided by key element. You take the last simplex table, then you take the, from xb onwards you take the values, then divided by the key element value, that is 4. Key element value, that is 4. So 12 by 4, 4 by 4, 3 by 4, 0 by 4 and 1 by 4. Then you calculate the values and put it into the that x1 table, x1 row. x1 row. So now your x1 row has been completed, and the CB objective function of x1 is 7. So that is why CB value of x1 you take it as a 7. So the rest of the values you just before you calculated, so you put the values into that particular cell. So this is the way you have to calculate the new row values. Then once again I will tell you how to calculate the existing row values. So I will tell you the second part, the existing row values. So this is the way you have to calculate the existing row values. That is S1, original element minus key column element in the existing row into incoming activity. Original element minus key column element in the existing row into incoming activity. Here original element that you have to take from the simplex table 1 final matrix minus key column element in the existing row, that is just above the key element. There is in the same key column the value of that is called S1, value of S1 in the key column. So in the x1 column, that is 1. So you take 1 for all that values, then multiply 1 with the incoming activity. Incoming activity means say 3, 1, 3 by 4, 0 and 1 by 4. That is called incoming activity. That is the newly calculated values are called incoming activity. So based on which you have calculated the values like 3, 0, 5 by 4, 1 and 1 by minus 1 by 4. Then you plot the values into this S1 row, that is the existing row values. So now we have calculated the new row values and the existing row values of in the simplex table 2 situation. So now we are going for the calculation of Zj. Say 0 into 0 plus 7 into 1, that is by 7. That is 0 into 5 by 4, 7 in plus 7 into 3 by 4, that is equal to 21 by 4. 0 into 1 plus 7 into 0, that is equal to 7. And 0 into minus 1 by 4, and another one is 7 into 1 by 4, that is equal to 7 by 4. And now we have a 7 by 7, 5, 0, 0, that is objective function values. Then difference of Zj and Cj, 7 minus 7, 0, 1 by 4 is the next value, 21 by 4 minus 5, then 0 minus 0 is 0, 7 by 4 minus 0 is equal to 7 by 4. So look at this table, all the Zj minus Cj values are positive. So you can call it as a solution is said to be an optimal one. So now all the Zj minus Cj values are positive, then you can call it as the solution is optimal. Then here the second simplex table, you can see that all the Zj minus Cj values are positive, hence the solution is optimal. Then we can based on CB column value, you can say that S1 is equal to 0. You look at the CB column value of the simplex table 2, S1 is there, S1 is not there, S1 is there but the value is 0, S2 is not there, then you give the value as 0, X1 is there, S1 value is 7, and X2 value is there not in the CB column, so you take it as 0. Then you can rewrite the objective function as a 7x1 plus 5x2 plus 0x1 plus 0x2. You put these values into this equation, that is 7 into 3 plus 5 into 0 plus 0 into 3 plus 0 into 0, that is equal to 21. Hence, the maximum value of Z in this particular maximizing simplex problem is equal to 21. So, this is the way you have to calculate the values. Now, the solution of a decision variable will be, that is maximum value of Z is equal to 21. So, this is the way you have calculated a maximization of a simplex problem with a less than or equal to sign. And thank you for watching all this. Have a nice time. Take care. Bye.